This is another example to give you how to use the problems of maximum and minimum in real life or in practical situation. So let's look for the worked example. Page 222. Right, so the diagram here shows a sphere, and inside the sphere there is a cylinder, right? So the sphere and the cylinder is inside the sphere. The height of the cylinder is equal to h. The radius for the cylinder is equal to r, but the radius for the sphere is equal to 5, right? There is a very important thing that I need to say here, that the center of the sphere is this point, and this point is exactly the middle. Well, it is the middle of the straight line passing through the center of the center of the circle, the top of the cylinder, and the center of the circle on the base of the cylinder. So if this is C1 and this is C2, I know that the distance between C1 and C2 is equal to 2h. The center of the sphere is exactly the midpoint. So I know that this distance is equal to h. So this is just to tell you later what we are using. Right. They tell you what else? They tell you that the volume of the cylinder is equal to C. So this is the volume of the cylinder is equal to C. After that, they asked you to express R in terms of H. So this is R is the radius of the circle, H is this part, right? So if you focus a little bit in this diagram, I will see that I have a right-angled triangle here. Right, this one is a right-angled triangle. I don't know, last year normally you studied how to solve problems in 3-dimensional. So normally you solve something like that. And I have a right-angled triangle. I know the hypotenuse, I have R here and the other side is H. So using Pythagoras gives that h square plus r square is equal to 5 square. So I can write r in terms of h. So r square is equal to 25 minus h square. So r is equal to the square root of 25 minus h square. So I only take the positive value because the radius is always positive. So this is the expression of r in terms of h, and it's in centimeter. Right, after that, they ask you to show that V is equal to 50 pi h minus 2 pi h3. Well, I suppose that V is the volume of the cylinder. It's funny, they say that it's a C in the exercise, but later they changed their minds, I think. So V is the volume of the cylinder, not C. It's a typo there. So V is the volume of the cylinder. The formula for the volume of the cylinder is equal to the area of the circle multiplied by the height. So the area of the circle, it's pi times r square multiplied by the height is equal to h. So it's equal to 2 pi r square h. I know the expression of r in terms of h, so I just need to substitute that. It's 2 pi times the square root of 25 minus h squared times h. So the square root and the square kill each other. So I will have 2 pi h times 25 minus h squared. I expand this, so it will be 50 pi h minus 2 pi h cubed. And this is exactly what I asked you to show, right? Find the value for h for which there is a stationary value of v. So whenever they ask you to get the value for stationary points, you just need to get the derivative dv dx, and then you dv dh, sorry, and then you solve dv dh is equal to 0. So I'm looking for the values of v of h for the dv h is equal to 0. So the first thing I need to get dv dh. I need to derive this expression. So the derivative of this expression is equal to 50 pi minus 2 pi times 3h to the power of 2. So 6 pi h squared. So this is the derivative. Now I need to solve dv dh is equal to 0. So 50 pi minus 6 pi h squared is equal to 0. So h squared is equal to 50 pi divided by 6 pi. So h, since it's a positive value, h is equal to pi, they kill each other. I can simplify by 2. So it will be the square root of 25 divided by 3. And it will be 5 divided by square root of 3. So I will write it here. Go ahead. So h is equal to 5 divided by square root of 3. And since we hate having a square root number in the denominator, I will multiply both sides by square root of 3. So 5 square root of 3 divided by 3, and this is the value of h. So this is a value, this is stationary point. And till now, I don't know if this is a maximum or minimum. I just know that this is turning point. So to know what is the type of this one, I just need to get the second derivative and see the sign of this when h is equal to 5 square root of 3 divided by 3. So the second derivative, dv dh squared, is equal to 1. I already know that the first derivative is equal to 1. It's equal to 50 pi minus 6 pi h squared. So deriving this, the first part is equal to 0. The second part is equal to negative 12 pi h. So substituting with this one, when h is equal to 5 square root of 3 divided by 3, dv squared dh squared is equal to negative 12 pi times 5 square root of 3 divided by 3. So it's negative 12 divided by 3, it's 4. So negative 20 pi square root of 3. And this is negative. So since this is negative, I can deduce that the stationary value is a maximum. Is a max. So since the stationary value is a maximum, is negative, the second derivative when h is equal to the stationary value is negative, then this is a maximum. Okay,